So in this video, what we will do, we'll understand the concept of weight. Okay, we have known about weight, from our normal conversation. But basically, what I want you to focus on is the weight and mass. Many of you might have a confusion; they both are same thing, but it's not. Okay, mass is constant of any object, no matter where that object is. But weight is not constant. Weight depends upon where you are measuring the weight. For example, the weight of a person on Earth, it's different than weight of the person on Moon. Okay, but the mass would be same everywhere. Okay, so those kind of topics and what's the concept behind weight, that we will try to understand in this video lecture. Okay, just to give you a little bit of flavor, if you look at here, we have two person, right? One is actually lifting a small stone. Let's say the mass of the stone is 1 kilogram, right? And mass of this stone is like 100 kilogram. Okay, now why the person has to apply so much force to lift the stone up, and why the force is actually higher when the mass is higher? What is the relationship between mass and weight? We will talk about those kind of questions. Okay, now one thing I would like you guys to just remember, I think in a motion chapter we discussed about maybe not motion, probably in the fourth chapter we discussed about mass and inertia. We know mass is a measure of inertia. Okay, the higher the mass, more the inertia. Okay, that's what we discussed before. In this video lecture, we will discuss about weight. Okay, now very high level definition, and this is just to get the discussion started. If I want to talk about weight of an object, then it is the force with which it is attracted towards the earth. And when I say towards the earth, that's when I'm measuring the weight on earth. Okay, so if I want to write it correctly, that would be weight on earth of an object is the force with which it is attracted towards the earth. Okay, so if this is a ground and this is a object, let's say, then the amount of force this ground, which is earth here, is applying on this object. We know from gravitation force that there is a force acting on this object because of earth, right? So that force is acting on this object F. That force is actually the weight. So weight and force have the same units. Okay, so the weight on earth, I'm going to say, is equal to force which is applied on the object by the earth, or the force with which it is attracted towards earth. Okay, I hope that was pretty clear. Okay, so now we know from our previous lectures that force is basically mass into acceleration. Right, now we know when an object is near the earth, the acceleration which is because of the gravitational force is acceleration due to gravity, and we have represented that in the previous lecture by letter G. So weight is mass into G. Okay, now we know the value of the G from our previous discussion. We know it is about 9.8 meter per second square. Okay, so that's the relationship between weight and earth. So weight is equal to mass into gravity. Gravity, we know the value of gravity. Now this value is true for objects near the surface of earth. Okay, so just remember that conventionally when we talk about weight of any object, we talk about weight of that object on earth. Okay, now if if someone is asking you specifically what's the weight of an object on Sun or Mars or Moon or Pluto, then you need to know the acceleration due to gravitation on that particular planet. Okay, but the relationship between weight and mass is weight on Earth is equal to mass into acceleration due to gravity. Okay, so as we can see here, weight, I'm gonna use a different page here. So weight is proportional to mass, right? Because weight is mass into acceleration due to gravity. So more the mass, more the weight. Now if we go back to our previous example of the person lifting a stone of 1 kilogram compared to person lifting the stone of 100 kilogram, the weight of this stone is pretty small. So weight in this case is going to be 1 kg into 9.8, right? Newton, because the unit of the weight is same as force. And this, let's say this is W1. W2 here, which is weight of this stone, is 100 kilogram into 9.8, right? So that would be 980 Newton. Now since the weight 2 is much higher than the weight 1, so in order for the person to lift the stone, he has to apply the same amount of force as the earth is applying to lift it up, right? So so the force which a person is applying on the stone 1 is going to be much smaller than the stone 2, because weight of stone 2 is much smaller or much higher than the weight of stone 1. Okay, now let's talk about the unit. So as I said before, the weight has a similar unit, same unit as force, so that would be Newton. Okay, and we know from before this is equivalent to kg meter per second squared. That is SI unit, and converting into the conventional units of mass and acceleration as we know. Now one more point I would like to make here is since weight is proportional to the mass, that's why there is a lot of confusion. People use weight or mass interchangeably. But I would like you guys to remember they are not exactly the same thing. Weight is more like a force, while mass is a measure of inertia and it is constant no matter where the object is. Alright, let's do a problem here. Simple problem that the mass of an object is 10 kilogram and the question is asking what is the weight of this object on the earth. Okay, so if I want to draw it out, this is our ground, this is an object, it's 10 kilogram, and then it's asking us to calculate the weight. Okay, now so if I want to write m is equal to 10 kilogram, that is what is given in the problem. We know weight, which I'm denoting by W here, is equal to mass into gravity, which is true for objects near the surface of Earth. We know gravity is equal to acceleration due to gravity is equal to 9.8 meter per second square. So weight of this object on Earth would be 10 kg into 9.8 meter per second square, which is going to be about 98 kg meter per second square, and we can also say it is like 98 newtons, right? That's a weight. So let's move forward.